All right, so yesterday on section 8.4, we talked about trigonometric substitution. Um, I gave you guys a couple of notes, right? I told you that we're going to be dealing with things that may have square roots that might have a constant squared minus a function squared, or the square root of a constant squared plus a function squared, or the square root of a function squared minus a constant squared, right? And I told you, remember your basic Pythagorean triples. Okay, so your sine and cosine relationship, your secant tangent relationship, and your cosecant cotangent relationship, right? So I was just kind of showing that to you guys so you guys can kind of see what you needed to know. Aside from that, I went through and I showed you guys the 3 different ways that you may possibly have to do one of these problems, okay? So method number 1 is if you have a square root of a squared minus u squared, okay? So that's method number 1. If you have that, then you're going to let u equals a sine theta, and then you'll let your square root of a squared minus u squared equal to a cosine theta. Second option was if you had a square root of a squared plus u squared, or u squared plus a squared, doesn't really matter since it's addition. But if you had one of those and your let statement is let u equal to a tangent theta, and then you're going to let your square root of a squared plus u squared equal to a secant theta. Okay, and the last one was this here. Anything that had integrals involving the square root of u squared minus a squared. So if you had that type of look, you let u equal to a secant theta, and the square root of u squared minus a squared should be a tangent theta. Remember, those triangles that I was drawing are there for the very end of the problem. Okay, at the very end, you're going to have to do a evaluation of your final solution, because you're going to have to put it back to normal. So right here we did example 1. We started off with something that was in terms of x. I noticed that we had a square root of an a squared minus u squared. So that means that we have to use this situation here, okay, based on the definitions. Okay, so we let u equal a sine theta, and the square root of a squared minus u squared equal to a cosine theta. So we just got to figure out what is u and what is a. Well, our a term was 3 and our u term was x, so I start plugging those things into the let statements, right? So you can see all that right here. Okay, we did the work for x. We did dx when we took the derivative. We substituted in for the square root, and then we figured out what x squared was, because we still had to know what x squared was in the actual problem. Okay, so this is what I'm talking about right here. Okay, this x squared had to be figured out. Okay, so we just squared the original x definition, and that's how we got x squared. Once we got all that, we substituted. That's all the blue stuff, right? So we substituted in for that, kept working, and you notice we got our answer right here. Okay, up to this point, we got our solution, but it's in theta form, right? This problem started in x form. So what I have to do is I draw this triangle on the left side, fill it in with the information. Remember, that triangle was given to you in the definitions. And I filled it in with the information that I needed to get, the u, the a, and the square root portion. And then I just asked myself, what is cotangent of theta based on that triangle that I drew? We found out that it was the square root of 9 minus x squared over x. So then I just plugged that in, and I have my answers in terms, or my answer in terms of x. Okay, so it's a bit of a process to go through all that stuff. Okay, but that's how it gets done. Okay, you guys have to do it that way. So let's do another example. We'll do example number 2. So we did example 1 yesterday. We're going to do example 2 right now. So we're going to evaluate the integral of, I'm just going to put dx over square root of 4x squared plus 1 Okay, so that's the thing they want me to evaluate. Now, you're going to notice that this looks like a u squared plus a squared, or you could say a squared plus u squared. Okay, but you're going to notice it looks like that. So what we're going to do is we are going to use our substitution that was given to us, right? So this substitution for us is step 2 substitution, right? The second substitution would basically says identify your u and your x. So right here u would be 2x. Identify your a term. A would be 1. And then start with your let statement. So let u equal to a tangent of theta. And then you're going to let your square root of a squared plus u squared, or in our case u squared plus a squared, equal to a secant theta. Okay, that's what our square root is going to be. A secant theta. So that's our let statement. So let's go ahead and do that. Okay, we're going to fill in our information for our let statement. So remember, this is what's given as the formula. So let u, which is 2x, equal to a, which is 1, tangent theta. Well, I don't want to have a 2x. I want to have an x. So I'm going to say, let's set x equal to half tangent of theta. Because I got to take a derivative. Remember, I need a dx. So I'm going to take a derivative of it. So dx is equal to 1/2 secant squared theta d theta. So that's what dx is equal to. 1/2 secant squared theta d theta. Okay. Now, from there, we're going to use our definition for the square root portion, right? So the square root of 4x squared plus 1 is a secant theta. Well, that's just 1 secant theta. So notice I have my substitution for the square root. I have my substitution for the dx, so I can actually do that now. Okay, so this is equal to 1/2 integral secant squared theta over secant theta d theta. Okay, now at this point, I simplify. Does anybody remember what the integral of secant theta was? I know last year when I mentioned it, I said you guys have to memorize it, but if you don't, look at your notes. Okay, those notes that I gave you guys with the, I don't even know, like 20 pages or whatnot. I'm not sure how many pages it was. But right there, you're going to see that the integral of secant of theta is something you're going to want to memorize, okay? It is ln of the absolute value of secant theta plus tangent theta. Okay, that is the integral of secant theta. Remember, we did this for homework. I don't know if you guys remember this, but we did that definition for homework last year. We were figuring out how to do the integral of secant, the integral of cosecant. I made you guys do it for homework. So once we have that, let me just clean this up a bit. 1/2 ln of this. I can't just say that that's my final answer because my original problem started with x's. Okay, I need it to be in terms of thetas. Sorry, I can't have it in terms of theta. I need to have it in terms of x's, right? So this is where I draw my triangle. Now remember, my definition here, I'm going to circle it here. Actually, let me go back up a little further. U is equal to a tangent theta. That means that tangent of theta is equal to u over a. Okay, u over a. Now u is 2x and a is 1. Okay, so it's opposite over adjacent. That'd be 2x, 1, square root of 4x squared plus 1. That's the way it goes. So based on this definition, secant of theta, according to this, okay, secant of theta, remember cosine, which is the reciprocal of secant, right? Cosine would be adjacent over hypotenuse, 1 over that square root of 4x squared plus 1. So secant is just the square root of 4x squared plus 1. Tangent of theta would be opposite over adjacent, right? We know that to be 2x. Right? We actually had it right here in this definition right there. Tangent theta is 2x. So let me go ahead and just plug everything back in, and then we're done. So this will be the square root of 4x squared plus 1 plus 2x plus c. And there's your integral of 1 over the square root of x squared, 4x squared plus 1. Any questions on this one? Give it a couple seconds here. All right, so we're going to do another example that's going to look very similar to example 2, just that I'm going to kind of change what's happening with the square root, okay? So example number 3. We're going to evaluate, and we're evaluating the integral of x squared plus 1 to the 3 halves dx. Now I do want you guys to notice that x squared plus 1 to the 3 halves is the same as the square root of x squared plus 1 to the third. Okay, so that means we're dealing with the same type of function that we had in example 2, a u squared plus a squared function. It's just being cubed, okay? But it doesn't change the way we're going to do the work. I'm going to note that I'm going to let u equal to a tangent of theta, and the square root of u squared plus a squared will be a secant of theta, okay? So I'm going to notice that that's the pattern that I'm going to be looking at. Now just so we can see, our u term is x, and our a term is 1. Okay? So, let me see. Sorry, I got a pop-up over here from a teacher, so I was just kind of looking, wondering what happened here. Anyway, so let's go with what we have. Let u, which is x, equal to a, which is 1 tangent of theta, so there's x. That means dx is secant squared theta d theta. Okay. So I have my derivative. I have my x value, and then I need to know that the square root of x squared plus 1 is a secant theta, which is just secant theta, but I don't need the square root of x squared plus 1. I need the square root of x squared plus 1 cubed. I need to be cubed. So that means that this is x squared plus 1 to the 3 halves. That's secant cubed theta. Okay, so now I have all my pieces that match. I have my x squared plus 1 to the 3 halves, and I have my dx. So we're going to start off by substituting. So I know that dx is, where's dx? Secant squared theta d theta over, and the bottom portion is just secant cubed theta. If I simplify this, I just get 1 over secant theta d theta, which is cosine of theta. And I know that cosine of theta is just, or the integral of cosine of theta is just sine of theta. So now to figure out what sine of theta is, I'm going to build my triangle. Now remember, according to this definition right here, tangent of theta is u over a. Tangent of theta is x over 1. So this is x, this is 1, so that's the square root of x squared plus 1. Okay, so sine of theta is equal to x over the square root of x squared plus 1. So I don't care if there's a square root on the bottom. That's perfectly okay. Remember, that's just something we make you guys do at first just to practice rationalizing. But once you know how to do it, we don't force it on you guys. So there's my answer for that problem. Any questions on that one? Where does the x equal to tangent theta? Are you talking about this step right here? Okay, so that comes from this definition up here. Let u equal to a tangent theta. Since I know that u is equal to x and a is equal to 1 based on the definition from the top, then I just plug those numbers in. So u is x, and a is 1. So that's how we get x equal tangent theta. So all this stuff basically translates to this. Any other questions on this one? All right, so let me see. 27, 11, okay, good. All right, let's do one more that looks kind of like the one we just did, but it's going to be a little bit more complicated. But it's almost going to look identical. You're almost going to say like, okay, we've done one like that. But in this case, you're going to have to complete the square of the denominator. Okay, so let's evaluate. By the way, a lot of these things are going to have square roots and stuff, so expect that, okay? That's the whole point of this lesson, is that we're supposed to end up having square roots for this stuff, okay? So let's see, this is going to be x squared. Hold on, where is that at? Yeah, x squared plus 4x to the 3 halves. Now remember, x squared plus 4x to the 3/2 is the same as the square root of x squared plus 4x to the 3rd. Okay, but I want you to notice this is my u term. U is equal to x. But my a term cannot be 4x. My a term is just supposed to be a constant. Okay, so that's not going to work for me. The way it looks does not work. So what I'm going to have to do is I'm going to have to complete the square inside of that radical. So let's just kind of work on that on the side, okay? So x squared plus 4x is the same as x squared plus 4x plus something minus something, right? That's the way we complete the square. Now the way we get the values that go inside of those underlines is we get our b term. Remember, this is our b term right there. We're going to divide it by 2, and then we're going to square it. So 4 divided by 2, that's 2. Squared is 4, so we're going to put 4 here and 4 there. So this is basically x squared plus 4x plus 4 minus 4. Okay, now if we factor this, this is x plus 2 quantity squared minus 4. I want you to notice that all of this inside of that square, that's my u term. Because it's supposed to be a function, right? So there's a linear function, x plus 2. My a term is 2. Because 2 squared is 4. Okay, so now I know that this function right here has a u term of x plus 2 and an a term of 2. Okay, now I also want you to notice that the function, I'm going to write it up here. Actually, I won't write it up here. I'm just going to put equals square root of x plus 2 squared minus 2 squared. Okay? Notice it's a u squared minus a squared situation. Okay? U squared, like this. U squared minus a squared. That's what's happening. So what do we do if we have a u squared minus an a squared situation? So you're going to look back at your 3 definitions, and it says, in the situation where you have a u squared minus a squared problem, you're going to let u equal to a secant theta, and your square root of u squared minus a squared will be a tangent theta. This is definition number 3, okay? Of those 3 that are listed, this is definition number 3. So notice we've done a definition 1, we've done a definition 2, this is a definition 3. So I've shown you one example of each, or at least showing you the 3rd one right now. Okay, and remember, the way we got here, we started off with the original problem, but you notice that I was able to figure out that u was x, but I didn't know what a was, right? A equals, I have no idea. So that means I can't use that u equal to x and a equals to I have no idea, right? I can't do that. So I said, okay, since a cannot be 4x, because remember our a term is a constant, since it can't be 4x, then I probably have to do something to that radicand, right? So I figured I'm just going to complete the square. So I completed the square, and I got a quantity x plus 2 squared minus 4. I noticed that I can write that as a function squared minus a number squared. So I say u must be x plus 2 and a must be 2. Okay. Once I did that, then I rewrote my square root. Okay, instead of it being the square root of x squared plus 4x, I wrote it as the square root of the quantity x plus 2 squared minus 2 squared, which matches the square root of u squared minus a squared. That's situation. Okay, once I know the situation that I'm dealing with, I can start off with my problem. So there it is. Let u equal to a secant theta. Let the square root of u squared minus a squared equal a tangent theta. So let's go ahead and start this. So u was x plus 2, a was 1. So that's secant theta. So that means that x is equal to negative 2 plus secant of theta. Okay. Actually, wait. No, I'm wrong. A was 2. I'm incorrect. Sorry. U is x plus 2, yeah, and this is 2 secant theta. I just remembered that a is 2. I just saw it right now. There's my u term, there's my a term right there highlighted. Okay? So, x would be negative 2 plus 2 secant theta. My derivative, well, negative 2 becomes a 0. The 2 secant theta becomes 2 secant theta tangent theta d theta. Okay, so there's my derivative. Notice I need to know my derivative because that's part of it, right? Right here. And then I need to know this part. I need those two pieces. So I got to figure out x squared plus 4x to the 3 halves. Okay. So the next part is the square root portion. But for us, the square root looks like this. X plus 2 squared minus 4. Well, according to definition, that's a tangent theta, 2 tangent of theta. Okay, but I don't need the square root of that. I need the square root cubed, right? It needs to be a power of 3 halves. So I got to cube this. In order to make it match the other denominator. So that's x plus 2 squared minus 4 to the 3 halves. That's 8 tangent cubed of theta. Again, I'm doing this because it has to match the denominator. Let's look at our denominator. Our denominator is x squared plus 4x to the 3 halves. I have it right there. I know it doesn't look like it, but if I expand it, that becomes x squared plus 4x to the 3 halves. Okay, so now I have what I need. Let's go ahead and start integrating. So dx would be 2 secant theta tangent theta d theta. Okay, the square root portion is 8 tangent cube theta. Well, I'm sorry, not d theta. What am I talking about? Okay, so it's just that. Well, that becomes 1/4 integral secant theta over tangent squared theta d theta. Okay, now you can do a lot of interesting things with this depending on what you want, but I usually like to simplify as much as I can. So let me do an extra step here. Secant theta times, that would be cotangent squared theta d theta, right? That's if tangent squared theta is in the denominator, I can bring it up as a cotangent. Let me rewrite those things in their basic form. This is 1 over cosine theta, and then this is cosine squared theta over sine squared theta d theta. That means I can cancel. And I have this cosine theta over sine squared theta d theta. Now I'm going to have to do a u substitution. Okay, but I can't let u equal to something because I already have u equaling other stuff, right? So I'm going to let gamma, or some people might say w, but it's gamma, alpha, beta. I mean, it's up to you. You can use alpha, beta, gamma. Delta is a little off because sometimes you use that for derivatives. Okay, epsilon I would rule against because it looks like your variable e. Okay, but I tend to stick with gamma. It's a lot easier to use. Alpha or gamma is fine. So we're going to let that equal to sine of theta. So d of gamma would be cosine theta d theta. So 1/4 integral 1 over gamma squared d gamma. Or you could just call it w, like I said. If it sounds weird to say gamma, just say 1 over w squared dw. The integral of 1 over w squared is negative 1 over w. Okay, so this becomes negative 1/4 1 over w plus c, which is negative 1/4 1 over sine. It was sine, right? Yeah. 1 over sine plus c, which is negative 1/4 cosecant theta plus c. So, in order to finish, you need to draw your triangle. Okay? Long problems, right? Very long problems. So we're going to draw a triangle. And I'm going to look back up here. I'm going to notice it said u is a secant theta. That means that secant theta was equal to u, which was x plus 2, over a, which was 2. Okay? So secant would be hypotenuse over adjacent. That's x plus 2 and 2. That means that this part must be the x squared plus 4x portion. Okay, or if you want to write the x plus 2 squared minus 4, that's fine. Whatever you want to put inside. But I'm just going with the shorter version. So cosecant would be hypotenuse over opposite. Okay? So my answer, finally, is negative 1/4 times x plus 2 over the square root of x squared plus 4x plus c. That is I mean, look at that. I still got to zoom out more and more. There you go. There's that problem. I'll zoom in right now. But this is why when our principal tells us, hey, you know, maybe just teach them for like 15 minutes and then let them have the rest of the class period to do stuff. And I tell them, some of my problems take 25 minutes to do. Like, how do I just teach them half and say good luck? Right? So this is why when you're in calc class, we do expect you to be able to keep your attention, right? To not get distracted, because some problems are quick and some of them are just torturous. Some of them you're like, are we done yet? Like, what do you mean there's still more, right? But yeah, some of them can take forever. Some of them are really quick, okay? So I'm going to send you guys your homework later on today, okay? Maybe during fourth period, I'll send it out to you guys. So you could kind of get started on that. Obviously, if you have questions, please ask. And if you want to ask anything right now, let me know. If not, third period is next. Have a good weekend, by the way. It is the weekend. See you guys.